Now that we have a proper understanding of working with abstract types, let's take a look at working with interfaces. Interfaces are similar to abstract classes in the sense that they can force implementations. While an abstract class can be thought of as a partial template, interfaces can be thought of as a contract, and whatever is in that contract must be implemented. Interfaces don't allow for any implementations and cannot contain fields. You are only able to use methods and properties. Interfaces allow for an important concept of object-oriented programming called polymorphism, where an object shares relevancy. We'll take a look at that in a moment. Let's say that we wanted to create a universal health system. We have our player and our enemy. They will have unique implementations, but we want to ensure that they implement the concept of health and have a damage method. We can use an interface to do this. So we're going to create a new C# script, and let's call this iDamageable. So typically when you're creating an interface, it starts with the capital I to signify it's an interface, followed by a name such as damage, and then usually it ends with an able. So you can have an iDamageable interface, an iFixable, iHealable, and so forth. Not required, but it is traditionally the standard. So let's open up this iDamageable and take a look at how to declare an interface. Now once that has opened in Visual Studio, you'll see here that we have an iDamageable class, and what we're going to do is convert this class to an interface. To declare an interface, we say public interface iDamageable. iDamageable does not inherit anything. So an interface is just going to be a contract, and whatever's in this contract we must implement for whoever implements this contract. So for the iDamageable, if we're creating a health system or a universal health system, we want to ensure that whoever implements this contract is going to have a variable for health. Now the problem with interfaces though is that we can't have public or private fields. Everything is assumed public. But I can't say int health. You are not allowed to have fields within an interface. You'll see here, interfaces cannot contain fields. What we can use are properties. So I could say int, and we'll say health, and we'll just have a get set implementation. What we can also have in here are methods. So we have a health property, and then we also have a damage method. So to declare damage method, we would say void damage, and it's just the signature. There is no implementation details allowed in the interface. All it is a contract, and whoever implements this contract must fulfill it by having a health property as well as a damage method. If we wanted to include a variable for damage amount, I could say here, like as a parameter, I could say int, and we'll say damage amount. Now, whoever implements this contract must fulfill this signature. So let's take a look at how to use this. We have an iDamageable interface that implements a health property and a damage method. If I save this, and let's create our enemy and player class. I'm going to create one for our player, and then I'm going to create one for our enemy. So new C# script, and let's create an enemy. Now once we've done that, let's create a cube to represent our player. And we'll rename this to player. And then let's go ahead here and attach our player script. And let's go ahead and create a capsule to signify the enemy. And we're going to attach the enemy script. From there, we can zero out these positions. So the player will say is -5, 0, so we can see it on the left side. And the enemy will put at 5, 0 on the right. So now they each have their own script. Now what I want to do is basically force the decision that they are going to have a health system applied. To do that for the enemy, what I could do is I can implement the interface. So to implement an interface, we go to enemy inherits model behavior, and then we hit a comma and we say iDamageable. Now as soon as I do that, you'll see here that the iDamageable is highlighted red, and it says does not implement interface member iDamageable.health and does not implement interface member iDamageable.damage with an int parameter. That means I have to include a property of type health, and I can say get and set. And then I also must include a public void damage method. And within that damage method, I have to include an int parameter, and I can say damage amount. And you'll see here that as soon as I added those methods, it's no longer erroring out. Now, once again, if I only include the health one and we save this, if I hop back into Unity here, it's going to compile and give us an error. It says does not implement interface member iDamageable. All right, so we need that damage method. Now, alternatively, one of the things I could do here is I could actually right-click this, quick actions and refactorings, and I can say implement interface, or you can do implement explicitly. Looks like they're both kind of the same. So here I'm going to say implement interface, and you'll see here that it's going to give me my property that was declared in the interface, as well as my damage method that was declared in the interface. So what this allows us to do is force that implementation. So here we have our health method and our damage system so that we can actually populate the functionality here. Let's say every enemy in our game and player, the damage system is unique, but what I can ensure is that when I'm attacking them, they have a health system implemented. So here I would then just be able to say my health property minus equals the damage amount. And now we have a universal health system. Likewise, I can hop on over to my player and we'll implement that interface as well. So here we are. Let's go ahead and clean this up. And we're inheriting from AutoBehavior, and then I'm going to implement the iDamageable contract. And when I do that, I need to fulfill the contract. So I need to go to Quick Actions, implement the interface, and if I didn't like the property settings here, I can just turn it into a traditional auto property. So I can say public int health get set, and there you go. So now both our player and our enemy are implementing their own unique health systems, but they're forced to have one. So that's the benefits of working with interfaces. Also, a nice benefit is that it creates what's called multiple inheritance. So traditionally, if I had another class such as our enemy, I'm already inheriting from AutoBehavior, which means I can't inherit from class enemy. You can only inherit a class once. You'll see here that it's red. Class player cannot have multiple base classes. You're not allowed to have multiple class inheritance. However, with interfaces, you can kind of fake the idea of multiple class inheritance. You can implement as many interfaces as you want. For example, let's say that we had a new interface that allows you to basically shoot. And what this does is creates a sort of plug and play environment. So if I were to create a new shoot interface, and within this interface, I'm just going to declare a signature for a shoot method, everyone who inherits or implements this contract is going to have a shoot method. So if we open up Shoot in Visual Studio, we'll turn it to an interface by going to public interface and removing the class. And here we have an interface shoot. Interfaces can't inherit anything. And then here, we're just going to declare a signature for shoot. So we're going to say void shoot. And that's all we had to do. Now, my enemy, for example, can have a shoot capability, and I can go over here and I can say implements iDamageable as well as implements the shoot interface. And as soon as I do that, it errors out because we're not implementing that shoot method. So I can right click it, quick actions, implement interface, and now we have a shoot method down here. So this is how we can kind of get around multiple inheritance, and it allows for us to create plug and play elements for our games. When we're creating new enemies, a designer could simply come in here and say, what do I need for this enemy? I need the enemy to have the ability, I need the enemy to have a health system, I need the enemy to have a shoot system, maybe a fixing mechanic, and you can do that all through interfaces and then force the implementations of these. So that wraps up working with interfaces. In the next video, we'll take a look at a practical example of working with interfaces and the concept of polymorphism.